Okay, my microphone's not going to work again. Okay, but now we're going to do 8-2, which is a z-test for a mean. Okay, so we are eventually going to do t-tests as well. So now I have to remember everything. So if my microphone's not going to work, I don't need to wear this thingy. Okay, so I'm clicked on the right thing everywhere. Okay, the z-test is a statistical test for the mean of a population. It can be used anytime the number of people, whatevers you have, are greater than 30. So that's the main thing we have to check for here. Or when the population is normally distributed and sigma is known. So that's our standard deviation. So that is one of the main things is that, so n is greater than 30, normally distributed, and theta is known. Not theta, sigma. Okay, so our z-test, we've already had seen this formula in a couple other places. It's your z-score is equal to x bar minus mu. So this is, remember x bar, oh, they're kind of down here but crooked. X bar is my sample mean. So that's just of the data you have. They might even say sample mean. Mu is the real mean. Sigma is their standard deviation, population standard deviation, and n is your square root of the number of things you have in there. Okay, note that down. Okay, so then we're going to do an example about that. 8.3, example 8.3. So I guess I forgot to make this click through it nicely, so ignore the answer stuff down here. A researcher wishes to see if the mean number of days that a basic low-price small automobile sits on a dealer's lot is 29. A sample of 30 automobile dealers has a mean of 30.1 days. That was 30 is important for basic low-price small automobiles. Okay, they want a, not confidence interval, but my, I really need to think of the name for that, figure that out, name out. What is that, alpha? I mean, I know where it is, I just don't know what we call it in this necessarily in this chapter. I'm going to call it confidence interval still. The test claims that the mean time is greater than 29 things. The standard deviation of the population is 3.8 days. So alpha, blah, 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 blah. So we need to go through this whole process, kind of like we were doing yesterday, of writing out our hypothesis and our claim. So our hypothesis, what is my next slide going to look like? Is going to have everything on it. So our first step, everything, just really break it down into the couple steps you have to do. So the first step is to write your hypothesis. Our null hypothesis says that it's the same thing that actually it was that we were given. Our alternative hypothesis, H1, is that it was greater than 29. Okay, so find the critical value. So alpha of 0.05 and a right-tailed test. So this is one of those nice ones to just kind of keep handy. Otherwise, you have to actually go in on your chart and find, okay, where is 0.05 on the right tail? Where's the top 95%? Top 95% happens at positive 165. Okay, so those ones, those are, if I don't have it handy, I'm always kind of saying this. Okay, so top, is it greater than that? So greater than is the top. So if this is 5%, this has to be 0.95. I'm using my chart to find 0.95, and then I do 165. Okay, compute the test value. So computing the test value, plugging in everything that we know into this one single formula today. So my X bar, the mean of the 30 that they actually sampled was 30.31. It should say in there something about population mean. I wish it would keep up the question. I should try to do that next time. The actual population mean was 29. The standard deviation, it told you like on that last line, was 3.8. And we sampled 30 total things, so 30 goes under there for their squared in. In your calculator, do the top separately, do the bottom separately, so that things work out nicely. Okay, next thingy, so they just kind of talked about, okay, that's clicked. Okay, now you just have to look at all that data and make that decision. So the test value we ended up finding was 1.59. Okay, that's less than the critical value, so this is where it's actually helpful to draw a quick graph. So remember, if it's in this 95%, so if that z-score would basically be within 95%. So yeah, so when you make that little graph, I didn't really do it too detailed. So I had 0.05, 95, 0.95. My z-score was 0.165, that it needed to be above to reject it. So we just kind of say is 1.59 greater than this? No, it would be over here. I'm not rejecting the null hypothesis. And then, yeah, so it's kind of if it's in that biggish area, we're not rejecting things. Okay, and again, that sometimes could give us errors, but those are not the errors we can work with. We have to make the decision based on the actual mathematics. Okay, there's not enough evidence to support the claim that the mean time is greater than 29 days. Maybe if that mean had been, the sample mean had been really, really large, but 31 is still pretty close to, or 30.1, I don't even remember what it is. Okay, basically what I just said, it's not significantly higher. The difference might be due to just random chance. So basically everything I just said there. Let me click through that so you can read that stuff too. Okay, I just put all those in words. Let me get there. Next example. All this stuff is gross and you're having to type it in your calculator. So we're going to do everything on a stat list. Okay, so you go into stat, edit, blah, 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 type in all this stuff. When you type in all this stuff, it's going to give you your sample mean, which will look like SX, I think, in there. So you're going to be looking for, I think it's big S, little x will basically be, no, it gives you X bar. We don't want that. It gives you X bar. So we'll need to know X bar after you type things in. Other things the calculator gives you when you do your 1-var stats, I think is what it looks like. So I have X bar. What else do we need? We need our sigma. So it'll find your sigma for you. Oh, it tells you that, so we don't need that. What else? We need our n. So to find our n, we actually have to count how many things. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 3 times 12, so 36. Hopefully there's nothing bad. So our n is 36. Our mean, our actual mean, the mean that they actually already have is $80. Hey, look, it said 36 up there. Okay, so the researcher wants to know is the average cost of the men's athletic shoes less than $80. So our null hypothesis is going to be H sub 0 colon mu equals 80. That's just always what it is. Okay. And then our null hypothesis, this is a 0, it kind of looks funny, is H sub 1. Or our alternative hypothesis, I don't know what I said.
You said no.
I did. So this one's a null, this one's alternative. Is that, and he says less than 80. So less than 80. Okay, so that's what our null and alternatives would look like. Next steps, so remember, like, you just have those steps written down from yesterday, so just keep those handy the whole time, just to make sure you answer everything. Next part of it, let's see, will it do the next thing? Didn't do anything? Okay, hey, look at that. Find the critical value. Our critical value is going to come from the alpha 10%. So our critical value is looking at our charts of all our z-scores. So we have to say, I think it's weird to try to do left and right hand. That just, I don't know, in my mind that doesn't seem to make sense. So I draw myself a picture. Okay, and that's what I always have to do. Okay, so I want it to be less than 80. So I'm testing that, so it's the bottom half. I kind of just look at which way I'm pointing with my stuff. less than there. So this has to be 10%. It's not two-tailed. Remember, two-tailed would be when I split it into, I think we'll probably have one. I don't even remember what examples we have. And this here would be a 90% here. Okay, this one is easy to find because it's just going to be, we're looking for 10%, so 0.01. Closest I find, so I have 102 and 0099, and that looks like negative 2.33. Negative 2.33 is our critical value, so just kind of make a note somewhere in there. Critical, and this is a z-score. Z equals